Okay, so for Form 5, we have a few chapters, and then chapter 1 is one of the easiest chapter to score. Remember, it's easiest, so please, although your school haven't start, but we start first, okay. Some of the school they teach already in Form 4, right? Some of the school I know that at the end of the Form 4 they started the Form 5 syllabus. So for first chapter is actually quite easy to score. So if possible, score for this chapter. Okay, so first chapter is about circular measure. That means we will deal with circle. Okay, if you still remember, circle, there is a few parts of the circle, right? Okay, see here, Okay, for a circle, we will have a line, right? Okay, circle. Okay, a line, the outline of the circle, we call it circumference. If you still remember, circumference. Okay, and then in the circle here, we have a dot, right? So this one, we call it a center. Okay, from the center, you join a line to the circumference here. We call it radius. Okay, simple one, still remember, Okay, if you have double of the radius, that means from circumference, pass through the center, go to the other side of the circumference. This whole thing, this long one, we call it diameter. Okay, very simple, right? Okay, and then for circle here, you will have this curved line also, this part. Okay, this curved line. Okay, if it is part of the circumference, then we call it arc. A-R-C, arc. Okay, the whole circle, we call it circumference. Part of it, we call it arc. Okay, and then the angle at the center there, normally we will use the symbol theta, or you use any other alphabets can also, no problem. Okay, so circumference, arc, radius, diameter, center is a dot, and also this angle, we call it angle, okay? And then if we have a circle, okay, so if I cut it, okay, let's say like birthday, you cut a cake, right? If I cut it like this one, center is here, so this part, we call it sector. This piece of cake, we call it sector. Okay, since it is a small one, so we call it minor sector. Okay, if it is over the other side, this part, over this side, okay, over this side is a bigger piece of cake, right? So we call it major sector. Major sector. Okay, so this cake, if I slice it like this, I cut it like this, okay, then this part we call it a segment. Small one, so we call it a minor segment. Minor segment. Okay, bigger part here, major segment. Okay, can remember all the names of the circles, right? Am I going too fast, or are you okay with this speed? Okay, okay, very good. Okay, so in this chapter we will deal with all these things. Okay, the name I wrote just now, okay, you will need to deal with all these things. Okay, so for the very first part of the chapter, we deal with the angle first. Okay, normally angle, okay, previously we measure the angle in degree, so it's like 30 degree. The small circle here is the unit for angle. Okay, in maths, we have another unit for angle, which is radian. So RAD. So let's say we have pi. Okay, and I use RAD, that means radian. Short form is RAD. Okay, this is another unit for angle. So degree and radian, both are the units for angle. Okay, if I have degree, I want to change it to radian. If I have degree, I want to change it to radian, okay, I will need to times it with pi over 180. You will need to always remember, degree is always a bigger number. Degree is a bigger number. Okay, radian is a smaller number. So you times pi, which is a smaller number, right? Divide 180. So you get smaller answer here. So hold on. Where is my blue color? Okay, this one. From degree to radian, you times it with pi over 180. If you want to get it from radian to degree, then you times it with 180 over pi. Okay, no problem. So for the very first part here, okay, we have the angle in measured in radian. So let's say this one 0.46 radian. Okay, if I want to change it to degree, the question asking us to change the following angles to degree. I want to change it to degree, so I will need to times it with 180 over pi. So 0.46 times 180 over pi. Okay, and then your pi is 3.142. So can you please take out your calculator and get the answer? What would you get? What would you get? How many decimal places are at least four significant figure, four numbers. If you want to make it safe, three decimal places at least. You can write more. Okay, 26.353. So 26.353. Okay, then this one is degree, right? So you put the little circle on top. This part, no problem, right? Very easy, right? Extremely easy, right? Yeah, the rest of you okay, Okay, let's try this one, What if I have pi here? This one, you see question number 6 here. Okay, you have like pi over 3 radian. So pi over 3 radian, we do the same also. Oh, sorry, I forgot these two people. Okay, pi over 3 radian, right? So if we have radian, we want to change it to degree, same thing, times 180 over pi, right? So this one, pi over 3 times 180 over pi. So simplify them, cut. Okay, do the same thing. 180 divide 3, so you get 60 degree. Boleh? No problem, Okay, for those who are new joining to the chat here, to the group here, to this class here, what am I talking about? Okay, the first thing we have learned here is the name for the part of a circle. Okay, circumference, arc, diameter, radius, center, degree, the angle. Okay, just now we go through this one. And then we go through this one also. We cut a piece of cake, small pieces of cake, we call it minor sector. Bigger piece of cake, we call it major sector. If I slice the cake like this small part here, we call it minor segment. Bigger part here, we call it major segment. Okay, and then the first thing we deal with is the angle. Angle can be measured in 2 units. First one is degree, another one is radian. Short form is RAD. Okay, if I want to change from degree to radian, okay, times it with pi over 180. If I want to change from radian to degree, times 180 over pi. Okay, Okay, so just now we go through 2 examples. First example is this one, 0.46 radian. I want to change it to degree because the question asking us to change the angle into degree. So change to degree, 2 degree, So it will be this one, times 180 over pi. So times 180 over pi. Use your calculator, you will get this one. Can follow, for the new joiner. Yeah. Can, The non-responding, I assume you okay, Okay. And then another example we try here is this one, pi over 3 radian. Depends on the question. Use directly the pi on the calculator. It depends on the question. If the question gives you the value of pi, then you will need to follow. If the question doesn't give you the value for pi, then you can use the calculator pi. Okay? Okay. Yes, correct. But normally, play it safe, you use at least 3 decimal places. So if you have like this one, pi over 3 radian, change it to degree, right? Times 180 over pi. Cancel the pi, and then you get the answer. No problem, Very good. Okay, like next one. Okay, I'm not going through all this thing. Okay, next one. Degree to radian. For example, this one. Convert each of the following angles into radian. So to radian, we times it with pi over 180. So for this one, times pi over 180. Okay, so use your calculator also. The question here saying that pi is 3.142. In case if this is in the questions, I mean in the middle of the calculation, you can maintain the pi. So you can do 26 divide 180. So you will get 13 over 90, right? 13 over 90 pi. If it is like the long wording questions later on, okay, in the middle of your working, you want to convert, right? You can keep this one first because this one will give you the most accurate answer. Okay, but if the question asking you to convert only, not finding anything else, so you will need to write it in decimals. Okay, so 13 over 90 times pi, right? 3.142. So you will get 0.4538. So this one is in radian, so RAD dot. Okay, no problem, Okay, right. Try question number 2. Can you get me the answer for question number 2? You will need to change the 37.5 into radian. Zero point. Yeah, correct. 0.6546. 0.6546. Okay. Okay, next one. New thing to you also. In degree, right? Okay, you will see something like this one. This is the unit for degree also. Okay, for the first one, you have a small circle here. We call it degree. Second one, you have a apostrophe, a comma like that. Okay, this one we call it minute. So this is degree. This is minute. Okay, you have 146 degree, 15 minutes. So in your calculator, actually there is a button like this one, like a dot, circle, and then with a comma, 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 that one. Can you find that in your calculator? Got right? Yeah, right? Okay, so when you press in your calculator, you will need to press 146 and then that button, you will see a small cube on top of the number 146 and then that button, 15, that button. Okay, this one means 146 degree, 15 minutes. Okay, change it to radian. So continue to press times pi over 180. Boleh? Okay, so what would you get for this one? 2 point something, I think. Yep, correct. 2.5529. 2.5529. Okay, unit radian. Okay, no problem, Okay, this one is very important because the formula later on we will use the angle in radian. Okay, so this one is not given in the exact the formula list, so you will need to memorize it. Degree to radian is pi over 180. Radian to degree is 180 over pi. And then a general knowledge, which is very commonly used. Okay, if 180, then it 180 degree, it will be equals to pi radian. If it is 360 degree, it will be equals to 2 pi radian. Okay, this one is quite commonly used, not only in this chapter, but in the chapter later on also. Okay, so the first thing we have learned here is degree to radian, pi over 180. Radian to degree, 180 over pi. Remember, degree is always bigger number. So if you want to get bigger number, you times it with bigger value, 180 here. Okay, So now we go for the second part of this chapter. This is the first part. Okay, second part, we are going to find the length of arc. Length of arc. Okay, length of arc is part of the circumference, right? If you still remember in Form 3, if you want to find the length of arc here, let's say this one is 60 degree. Okay, let's say the radius here is 5 cm. Okay, if I want to find the length for this one, arc, okay, let's say I have a point here, A and B. Well, A, and this one is B. Okay, I want to find the length of AB. Length of AB. Okay, in Form 3, then you will do the formula 2 pi r, right? Circumference. Theta over 360 times 2 pi r. This is what you do in Form 3. So theta is actually the degree here, 60 degree over 360 times 2 times pi times the radius 5. Okay, this is the way, the old way you find the the length of arc. Okay, in Form 5 first chapter here, length of arc, we give a formula S equals to R theta, where the S is actually the arc. Okay, the R here is the radius. Theta here is actually the angle. The angle in radian. Okay, if I have the same questions here, I will need to change the degree to radian first. So for the same questions here, I want to find the length for AB. So I will need to change this degree, become radian first. 60 times pi over 180. Like I say just now, because it's still in the middle of your working, right? You can maintain it in pi. So here 60, 1, 3, right? So you get pi over 3, right? Okay, this is radian. Keep it in pi first. So S equals to R theta. Your radius is 5. Your theta is pi over 3. Like this. Okay. To find the value, the length of AB. So AB will be equals to, you use a calculator, 5 times pi over 3. In this case, if the question doesn't state what value of pi you use, then you can use a calculator pi. So here will be 5.2359, no, 60 cm. If this one is in cm, then your final answer will be in cm. Okay, right? No problem, right? Okay, huh? Okay, very good. This one. Here got 6 questions here. Okay, can you try first for these 6 questions? Can you see or not? I make this one smaller and maintain this one here. Don't use the old method, use the new one, S equals to R theta, this one. Okay, try this 6 question. Okay, we take like 5 minutes here. Mm. If you have question to ask, you can ask, huh? If you are shy to ask, you can private message also, huh? Sorry, and the JX in our group, in our WhatsApp group. Have you been admitted already? Okay, 2 more minutes, huh? You will need to be careful of number 6 because the question asking you to find the length for the other side here, not the minor one, is the major part here. So you will need to get the angle for this part first. Can I? Can I? Okay. So for the first one here, S equals to R delta, S equals to 4 times 0.83. This is radian already, so don't need to change. So you will get 3.32 cm. Second one, S equals to R delta, S equals to 6 times 1.36. So you will have 8.16 cm. Then for the third one, radius is 8, and then this one, you have the angle here already. So S equals to R theta, S equals to 8 times 4.968. So you will get 39.744 cm. Okay. And then the next one, S equals to R theta also. So R is 12, theta is 48 degree. So you have to change it to radian times pi over 180, like that. Okay. So here you will get 12 times 0.838. Or else you don't want to write this step, can also. You just press everything one shot in your calculator. So you shall get 10.056 cm, meter. Okay, and then the next one, S equals to R theta. S equals to R is 16, theta is 152. Yeah, 152. Change it to radian, so times pi over 180. So you will have 42.488. 42.448 cm. Okay, and then question number 6, you will need to find the other side, right? So take 360 minus 147. 360 minus 147 degree. So here you will get 213 degree. Okay, and then you change it. 0.54. Okay, wait, let me check later. Okay, then this one, S equals to R theta. So S equals to 20 times 213 times pi over 180. Okay, then you will get 74.36 meter. Okay, check my answer also, huh? If my answer is different from yours, please let me know. Pi over 180 times 12.
Teacher, can I ask
Yes.
the question number 1 until number 3? No need to use the pi.
No need, because here it gives you in radian already.
Oh, okay.
Uh-huh. So if you have radian directly from the question, you don't need to change. If you have degree, then you have to change. Yeah, for question number 4, if I use the calculator part, I will get 10.053. So, but it's not significant. So if you have like 0.53 or 0.54, it's okay. Both okay. 5.6 can also. Okay, so far, any questions for number 1 to 6? No, yes, the theta always in radian. Soka Towa, that one will be in degree. It will be different. For this formula, S equals to R theta, this theta always in radian. Okay, no problem. If there's no problem, then we proceed to the next part. For the new joiner, okay, we learn this formula, new formula, S equals to R theta, where the S is actually the length of arc. R is the radius, theta is the angle in radian. So radian is new to you, right? Okay. Angle, you have 2 units. One is degree, another one is radian. If you have degree to radian times pi over 180, radian to degree times 180 over pi. Okay, maybe you need to repeat the recording later, so that you can catch up. So the formula we have here is S equals to R theta. S refers to the length of the arc here. So the length here equals to radius times the theta, where the theta is the angle in the unit of radian. Okay, number 1 to 6, no problem. We go to the next part. This one. Okay, let's say, if we have something like this one, okay, question give us the length of arc here, PQ, which is equals to 12. And then the angle 0.8. And then the radius, we don't know what is it, R. So use the same formula just now. S equals to R theta, where the S is 12. 12 equals to radius, we don't know. So write back the R. And then the angle is 0.8. It is in radian, so no need to change. Okay, to find the R, so we'll take away the 0.8, right? So it becomes 12 over 0.8 equals to R. So R will be equals to 15. Okay, thank you, 15. So this one is cm, so here will be cm. So same thing for second formula, second questions. S equals to R theta. 7 equals to R theta is 0.845. So radius will be equals to 7 divided 0.845. No need to change also because it's radian. So second one, you will get 8 point something, 8.284 cm. Okay, no problem, Okay, then same thing also. I'll let you do these 3 questions here. Sure. This one. Question number 3, 4, 5. Okay, try on your own these 3 questions. Find the radius. This one's still the simple one. Five minutes, Your answer can be in decimal or fraction, up to you. Unless the question say like specific format, then you have to follow. Are we going too fast or still can follow? Okay. Please slow me down if you feel like too fast. Don't be shy. Okay, I think most of you can do. S equals to R theta, 16 equals to R theta is 122.6 in degree, so change to radian, times pi over 180. So radius equals to 16 over 122.6 times pi over 180. So this one radius shall be equals to 7.477 cm. Okay, second one, same thing also. 60 equals to R theta 3.96 is in radian, so maintain. Radius equals to 60 over 3.96. Radius equals to 15.152. Okay, the third one, also the same thing. S equals to R theta. Okay, 75 equals to radius theta 351.8. 351.75 times pi over 180. So radius equals to 75, divide that thing. 351.75 times pi over 180. So radius equals to 12.215 cm. Wow. Okay. Okay, settle. Then we go for next one. Okay, next part, the question asking us to solve each of the following. Okay, follow. Okay, solve each of the following. But this one is easier. Like just now also. Just now we find the f, we find the radius. Now we find the theta here. So for these questions, it will tell you whether it is in radian or whether it is in degree here. So it depends on the questions. Okay, do the easier one first. Question number 1. Find the value of theta in radian. So question asking for the angle in radian. S equals to R theta. S is the length of arc, 4 here. Radius here, 5 theta. So move the 5 away. So theta equals to 4 over 5. Or you can leave it in decimals, 0.8. Unit will be radian. Because this formula, the theta is in radian. So the answer you get is in radian. Okay, So second one also the same thing. S equals to R theta. 7.32 equals to radius is 6. Theta we don't know. Find the theta. Take away the 6. 7.32 over 6 equals to theta. So theta equals to 1.22 radian. Okay. Okay, fine. Next one. Question number 3. Okay, what if the question asking us for the value of x here, and this one is in degree. So if it is in degree, same formula also, don't worry. So S equals to R theta. 12.8 equals to radius 7. Theta we don't know. So find the theta first. The theta will be in radian. After you get the radian, then only you change. So theta equals to 12.8 divided by 7. So theta equals to, keep the long number in your calculator, 1.829, I think. Okay, after you get the radian, then only you change it. So x will be equals to, okay, change it to degree, 1.829 times 180 over pi. So use your calculator, 104.78, I think. Okay, no problem, eh? Okay, so one formula only so far, and two formula only so far. S equals to r theta, and another one is interchange of degree and also radian. Okay, like these two you try. Question number 4 and 5. Question asking us to find the angle in degree. So find the theta first. One, two, six, seven, eight. You can leave it in 0.08. Mm. Can I? So here S equals to R theta, 19 equals to 8, and then theta. Find the theta. So theta equals to 19 divided by 8. Show X equals to, or else you want to start from here using X can also. Doesn't matter. This one is in radian. Change it to degree. So 19 over 8 times 180 over pi. So you will get 136.08. If your answer is slightly different, doesn't matter, because 0.0 something, not really significant. But it must have 136.0. Okay, then next one. Same thing also. S equals to r theta, 68 equals to radius is 12. Theta we don't know. So theta equals to 68 over 12. and then change it to degree because here asking for degree. So x equals to 68 over 12 times 180 over pi. So x will be equals to 324.65. 324.65. Okay. Okay. Is it okay if my lesson? Yeah, it's okay. The main point is you have 324. Mm. The range is like plus minus 0.5, but it depends. Yeah. To get the more accurate and best. Yes, correct. The most accurate one will be the fractions. Okay? Okay, now come the exam questions. Exam style questions will be like these kind of questions, like the exercise 6 and exercise 7, like this. Okay, so just now that one is the basic one only. Normally, the question in the exam wouldn't be so easy one. Okay, let's see like the exam style questions. Okay, so the exam style question might be something like this. So, oops. Okay, the question asking you to calculate the perimeter for the shaded segment. So if you still remember what is segment just now, we slice the cake like this one. Okay, then this curvy part here, this one is called a segment. So if the question asking us for the perimeter of the segment, so for example, this question, perimeter of the segment, that means you will need to find the length for this one, this straight line, plus the length of this curve. Okay, so just now we learned already, the curve here, this curve is actually the S, right? So this one you use the formula S equals to R theta. Okay, so perimeter you will need to have this one also. So how do you find this straight line, the length of this straight line? If you can recall the memory in your form 4 syllabus there is a thing called cosine rule, right? Cosine rule, a squared equals to b squared plus c squared minus 2bc cos the a. Still remember this thing? Or else the ABC something different is okay also. Some of you like start with c squared, can also. But this formula, still remember cosine rule? So for this one, 15, 15, like just now one of the students asked the SOHCAHTOA, is it in degree or radian? Okay, it depends on your calculator. If your calculator setting is D, your calculator, there is a small alphabet on top there, right? Writing D like that. If your calculator setting is D, that means it will be in degree. So you will need to change the radian to degree for this cosine rule. Yeah, if your calculator setting is R, that means it will be in radian. Then you don't need to change the 0.8. But for me, I would encourage the student to maintain it as D first because there is some of the chapter in the same paper. Okay, most of the angle are in degree. So especially when you do the trigonometry, the angle will be in degree, right? So you can maintain it in degree. So you change manually the radian to degree. Okay, so for example, this question, I want to find the perimeter, right? So straight line plus the curved line. So the straight line here will be PR, right? Okay, so PR squared equals to the opposite one, PR square equals to these two length, 15 square plus 15 square minus 2, 15, 15. Why this one is 15, 15? Because it is radius, radius, radius. So they are the same. 2, 15, 15, cos, and then the 0.8 radian here, change it to degree. Cos 0.8 times 180 over pi. So press everything one shot in your calculator, will be easier. PR equals to something. Let me use the 2r sine theta over 2. 2r sine theta over 2. Two r sine theta over 2. Okay, 136, that one, right? You have to square root it because it is PR squared. So PR equals to square root 136.482. Because just now the formula is PR squared, the A squared. You know, so for this one, when you do the square root, you will get 11.68 something, right? Okay, and then you plus the r theta. Okay, so this one 11.681, right? Yep. So S equals to r theta will be the curved one. So S equals to 15, 0.8. So this one you will get 12. So when you plus these two together, 681. So perimeter equals to 11.681 plus 12. So you will get 23.683 cm. Okay, okay. Okay, there is a student here asking whether we can use the formula of 2r sine theta over 2. That one can also, okay, you shall be getting the same answer also. Or else another method, you want to split it SOHCAHTOA, can also. I mean like you split this one 90 degree here, SOHCAHTOA, you find the opposite, can also. You will get the same answer. Uh, PR 2r sine theta over 2, right? But remember, because it is sine, right? So change this one to degree. Both also work. No problem, huh? Okay, like try, next one, wait. Radian. Okay, we try these two questions here. Number 4 and 5. This one. For the chord, you can either use the a squared plus c squared equals to a squared plus b squared minus 2ab sine c, or the 2r sine theta over 2, or the Sokato. And then the PQR, the S equals to R theta. These two formula. Okay, try. Okay, guys, try. See whether you get this answer. The question number 4 here, you shall get 71.615 cm. See whether you can get this or not. And then the next one is 90.407. I mean the final answer. See whether you can get it or not. Four. Okay, finish. Okay, let me know when you finish, ah. Mm-mm. PR squared. Okay, if I use the another formula, PR equals to 2R 2R sine theta over 2. So 216 sine theta is 2.56 times 180 over pi divide 2. If you feel like it's difficult for you to read, right? Then you change the radian on the other side. 2.56 times 180 over pi. You change first in degree. Write it on another place. Okay. This one is 146.67. So here you write 146.67 like this. I can also. So for this one, you will get 30.655, I think. Okay, and then the PQR equals to R theta. So 16 and then 2.56. So you will get 40.96. So for perimeter equals to these two plus together. 30.655 plus 40.96. So you will get 71.615 cm. Okay, so the same thing go to the next one, but your this one PQR is on the other side, right? So for the length of the arc here, you will need to have this angle. Huh. Okay, but I find this one first, PR first, yeah. So PR square equals to 15 square plus 15 square minus 2, 15 cos. For this PR, because it's facing upwards, right? So the angle is still the same, 1.86. So this one you will need to change it to degree. 1.86, make it smaller. Okay, 1.86 times 180 over pi, like this. So the PR equals to 24.047. Mm. And then for PQR, the other side, this one, you will need this angle. So if you still remember just now, 180 degree is actually pi radian. 360 degree is actually 2 pi. So in order to find this one, I can actually take 2 pi to minus. Over here, this angle, take 2 pi minus 1.86. Okay, so S equals to R theta. The S refers to PQR equals to radius is 15. Theta is 2 pi minus 1.86. Yep, 86, like this. Okay, so use the calculator, you shall get 66.36 cm. So perimeter equals to 24.047 plus 66.36. So 90.407 cm. Questions that will ask to prove 2 pi is 360. If the question asking you to prove that the 2 pi is 360, then you change it become the radian times 180 over pi, that one. Or you change the 2 pi become 360, you times 180 over pi. You use these two only. Okay, for this one, any problem? Okay, so far okay. Using the Sohcahtoa, that one. Okay, if you want to use the Sohcahtoa, can do also. Okay, so for example, question number 5. I think question number 4, everyone done already. Question number 5, if I want to find the chord by using the Sohcahtoa, so you will have this triangle here, right? This one. Okay, I draw it at the side. So for that triangle, show. Okay, you have 15, 15 here. Okay, this angle, just now we changed already, right? No. Okay, change this one, become degree first. 1.86 times 180 over pi. So this one, if I change it to 1.86 times 180 divide pi, change it to degree, I will get 106.57. If you want to use the Sohcahtoa, then you add a line here. This one, adding a line here so that you will get 90 degree. Okay, so this part and this part is actually the same length. Why? Because it is isosceles triangle here, 15, 15. So if I split into half, so this angle 106.57, you will need to divide them by 2. So you have this triangle over here, 90 degree. This one will be 106.57 divided by 2. So you will get 53.29. 285. 53.285. Okay, and then this one is 15. So you have the angle here, then this one will be the opposite. This is hypotenuse, right? Then you use sine. Sine 53.285 equals to opposite over 15. Find the opposite and then you times 2 so that you can get the whole thing of chord here. Okay, so a few methods to find the length of this thing depends on you. So if you feel like the cosine rule is easier, this one, the long one, then you use the cosine rule. If you feel like the this one is easier, and where am I? This one, 2r sine theta over 2 is easier, then you follow this one. If you feel like the SOHCAHTOA, this one is easier, then you use this one. Up to you. Okay, so far okay? Yep. Okay, if that's okay, then we go for the last part of this chapter, and not the last part of this chapter, last part of the lesson today. Basically, we have finished already 50% of the first chapter. In the first chapter, two major things only. First one is finding the length of arc, and then find the perimeter, like what we did just now. Second part is about the area. So the area part we will cover in our next week's lessons. So next week, by right, we shall finish chapter 1 already. So if you have friends who want to join, so please advise them to join within these two lessons. Because started from chapter 2, it will be extremely difficult for you all. Yeah. So if your friend join after we start the chapter 2, then it will be a bit difficult for them to follow. Mm. So these 2 weeks is still like honeymoon for you all because it's the easier one. And then the third lessons onwards will be a bit difficult. Mm. Okay. But it's fun also. Don't worry. A lot of the question will coming out for the chapter 2 and chapter 3. Mm. Yeah. If you survive here, then no problem one. When you go to school, you'll be the expert. Yeah. Okay. Okay, like this one, exercise 7. Okay, this will be the last exercise for today. Not this question, but this whole exercise, 5 questions. Okay, like question number 1, if I have this one, okay, the diagram shows a garden in the shapes of a sector. So since it is a sector, so here 16, then here 16 also lah. Okay, the garden has to be fenced. You want to make a pagar, the fence for this segment. So that means 3 side lah. 16 mn and also another 16. Calculate the length in the meter of the fence needed. So this one still easy, right? 16, 16. You will need to find this arc only, length of arc. Okay, so that means it will be the perimeter lah, the length for the fence. Perimeter equals to 16 plus 16 plus the r theta. Okay, try to find the perimeter. Okay. So 16 plus 16 plus radius is 16, theta is 2.265. Okay, correct. 68.24. 68.24. It is in cm, so this one in cm. Okay, Next one, huh? Oh, why cm? Okay, calculate the length in meter. Okay, guys, meter. Change it to meter. So it will be 0.6824 meter. I suspect this one it gives the wrong thing. The garden wouldn't be that small, cm. Okay, but doesn't matter. Doesn't matter. Okay, next one, huh? Question number 2. Wait, this one. Question asking us, the diagram shows a stage in the shape of a sector with a radius of 4. So it's a major sector here. Okay, the curved part of the stage will be decorated with ribbons. So this part will be decorated by the ribbon. Okay, calculate the length in meter of the ribbons needed. Very easy. Get the angle of this side, 360 degree equals to 2 pi. So you want to get this part, the angle of this part, you take 2 pi minus the 0.8 something. If you feel very confused, doesn't matter. You change the radian become degree. And then only you minus it. Can also. But more steps lah. If you change to degree and then change it back again. $29 point something. 21 point something. Don't plus the 4 because the question say the curve part only. So the angle equals to 2 pi minus 0.874. So the angle is 5.41, right? Radian. So S equals to R theta, 4 times 5.41 only. Okay, so the answer shall be 21.64. Good. 21.64. And then this one is in meter, so this one will be in meter as well. So far, okay? Okay. Right, one more question before we go, huh? Then we have question number 4 and 5, you do it at home. Okay, question number 3 here. It says that it is a plan for a resort that to be built OAB with a is a sector with center O. So sector, so this one 1.65 km also. Okay, given that the perimeter of the resort, perimeter. So find the AB first, then only you can find the angle. Okay, so find the AB first. AB equals to 7.425 minus 1.65 minus 1.65. The length of AB 4.125. 4.125. It is km. Okay, then S equals to R theta. Find the theta. (2.5 radian), correct. Okay, so 4.125 equals to 1.65 theta. Ouch. Theta. So theta equals to 2.5. Okay. Very good. Okay, so far no problem, huh? So these two questions, 4 and 5, will be your homework. And then later I send a few more past year questions. Okay, don't be scared. Still easy question, huh? Okay, so you try question 4, 5, and also the question later. If you have any questions, you can WhatsApp me anytime. Oh, you want the answer first, huh? Okay, no problem. Question number 4 here, the answer is 11.519 meter. Okay, and then question number 5 here is 35.18. Okay, so far our speed here is still okay, right? Can follow, huh? Do you have any questions so far? No? No? Yeah, very good. Mm-mm-mm. So if you can follow, then I'll see you in next week lesson lah, huh? If you have any friends who wants to join, advise them to join next week before we start chapter 2. Okay? And then after we start chapter 2, then we will go like yeah, I will be with you all. Okay, don't worry. Although it's difficult chapter. Okay? And we don't need to memorize the sine, cos, tangent for that one in this chapter. But for trigonometry, you will need to memorize it. Sine, cos, tan for the special angle. Okay? No question, then see you next week, guys. Goodbye. Have a nice day. Thank you, thank you, thank you. Bye bye.